Okay, so I'm going to do my presentation on Isaac Newton and his life and how his theories contributed to calculus. So, good stuff. My poster's right behind me. Let's see. Can't really see it too well. I'll post a picture of it so that way you'll be able to read each section. Here's one of the wings. Here's the other wing. Can you see that? Yeah, you can see that. And then here's the middle. See that? Okay. I'm just gonna leave that right behind me. So I'm just gonna talk about my poster, which is based off of my research paper. All right, so I'm gonna start off chronologically with his life. So I'm gonna start off with his early life. He was born January 4th, 1643. He was the son of a farmer who died 3 months before he was actually born. So he didn't have a dad, he only had his mother right now. Once he was born, he actually wasn't expected to live just because he was born weak and premature. He wasn't expected to live at all, but he did. He spent most of his early years with his grandmother after his mother remarried. So she actually remarried when Newton was 3 years old, all the way up until the age of 12. So during that time period, Newton was actually with his grandmother, so his mother kind of abandoned him. When Newton's mother came back, she brought back her 3 kids. She came back because her second husband actually died. So Newton was back with her mother, and yeah. So let's go into his education. He was actually working to be a farmer like his father, but that did not work out. So he failed as a farmer, and his mother pulled him out of school at the age of 12 when she came back. So then he was actually sent back to the King's School to finish his basic education. And then after he attended King's School in Grantham before enrolling in the University of Cambridge, Trinity College in 1661. That's crazy, because I didn't even know there was colleges back then like that. So, yeah. And during that was basically his prime time, where he discovered, theorized, and invented everything that we know about Newton today. So that's good. I'm going to skip a little bit of that. I'll go back to it in a second, but I want to go in chronological order and go ahead and finish with one wing. So I'm going to talk about his death and legacy. He actually reached the age of 84, which is crazy because not a lot of, especially men back then, lived up until this age. So it was really good that he actually lived up until 84. You saw how Newton's mother wasn't so lucky with her men dying left and right. He died March 31st, 1727 in his sleep. So not for too many days from now. So happy death day. I don't know if that was appropriate. And Newton's universal principles of gravity found no parallels in science at the time. During the 17th century scientific revolution, it was massive what he did. And it was very much unbelievable that he was able to figure out so much in such a short period of time. 84 years. He was the founder of calculus, although there's a little bit of controversy surrounding that. He was the founder of the thing that gives me stress every single night, calculus. His theories actually gave way to Albert Einstein's ideology, so Albert Einstein paralleled off of Newton, so that's a little crazy, you know? That's kind of, wow. So basically that was this wing right here. Now I'm going to talk about this wing over here. All right, so I'm going to talk about Isaac Newton's discoveries. So he discovered optics, motion, and mathematics. He made discoveries in those. He theorized that white light was a composite of all colors in the spectrum and that light was composed of particles. Good. He explained the laws of motion, and then he created the theory of gravity, which actually was the Apple myth, which I'll go into in a bit. And he was credited for developing essential theories of calculus. Although some were proven wrong in the end, a lot of it was pretty salvageable, and I mean, I use it in class today, so good job, Newton. So his inventions. He designed and constructed a reflecting telescope in 1668, and he used this telescope to study optics and help prove his theory of light and color. As a professor at Cambridge, he was required to deliver an annual course, and optics was his initial topic. So he was able to study one, optics and light and color, and two, create a telescope during that time, and then three, present it to his students in his university class. And then he was elected to the Royal Society and published his notes on optics for his peers. So not only that, but he was recognized very much widely for his optics studies, and it all worked out in the end for him, for optics at least, and gravity, of course, and calculus. He did a lot of good things. So I'm going to go a little bit now into what I said I was going to go into before, the Lebanese calculus controversy. So Newton had developed the concept of fluxations, but at the same time, or during the same period, German mathematician Gottfried Leibniz formulated his own mathematical theories. While Newton made his discoveries in 1664 through 1666, his findings were not published until 1693, big time period that passed by. And Leibniz, on the other hand, made his discoveries in the time frame of 1672 to 1676, but published them in 1684. So, as you can tell, obviously Newton came up with it first, but he didn't publish it first. So there's just a little bit of controversy in that. But Newton is a true founder, going based off of numbers and timelines. So now I'm going to go for the middle. So the apple myth. Between 1665 and 1667, Newton returned home from Trinity College because it was shut down because the plague, kind of like now with the coronavirus. Wow. He experienced his famous inspiration of gravity with the falling apple. He saw the apple falling from the tree, but he wondered why it didn't go from an angle and why it went straight down instead of an angle. And that's when he began theorizing like gravity and everything. So that's his initial, like, why he started even going in with gravity. So his theories of gravity, he has three basic laws out motion in the Principia, which helped him arrive to his theory of gravity. Yeah, so we all know gravity. I don't really need to go in depth with that. But the laws helped explain not only elliptical planets' orbits, but nearly every other motion in the universe. So his theories of gravity vastly and greatly helped in other areas of studies in physics and biology and chemistry and literally everything. So it was everywhere, gravity. And then now he also founded calculus, which was invented in 1665. He invented that. He focused on gravity and laws of motion, and those are linked through his breakthrough. He started by trying to describe the speed of a falling object, hence the apple. And then he developed the idea of rate of change, which I actually used in class. So thank you, Newton. And it's a direct link between mathematics and physics, especially physics. I remember taking physics last year as a junior, and Newton was all over our first semester, and first semester was a lot of gravity stuff. So he was definitely still used today. And yeah, so that's my presentation on Newton and his contributions to calculus. Once again, I'll put my poster on a picture, and I hope I get an A, and I hope I got that extra credit. Please, Plz Foshee, I am begging. I need this. But yeah. And I based off this presentation off of my work site, off of my research papers. So yeah, that was my presentation for AP Calculus, Plz Foshee, third period. All right.